The Elements is actually the book we're talking about. There's 13 books that cover many of the branches of math. Elements in this case is kind of like the atomic elements, at which time there were earth, air, wind, and fire were the main elements of the earth. And so Euclid used that term when he wrote his book, basically explaining what the elements, the main core elements of mathematics were. And like I said before, he laid the foundations for geometry. Everything that we learned in 8th grade or sophomore geometry is built within Euclid's whole first couple books. There's been over 1,000 editions printed, and it has had a lasting influence both on people in fields of mathematics. Book 1 is on triangles and Elements books. There's some discussion if it actually meant just like chapters or big sections or full books, but Book 2 is on rectangles. Book 3 is on circles. Book 4 is on polygons, and we all know what polygons are and how complex they get. Book 5 is on proportions. The side angle side part of geometry, that's where we get that says that two triangles are proportional to side. Similarities, we kind of have a good handle on what those are. Elements, books 6 through 10 are probably my favorite area of mathematics, number theory. And I'm really surprised there's that many books on number theory. Then we get to the solid geometry and pyramids, a whole book on pyramids. The guy lived in Egypt, so what do you expect? And Platonic solids. And he laid the, like I said earlier, this is the foundation of geometry. He has defined 23 different terms, has 5 postulates, 5 common notions, and these common notions, when I introduce them to you, it kind of makes sense to you a little bit. And the most important thing was, like I said earlier, is he systematically built the rest of the plane of solid geometry from these, he got the basics down to as minimum as he could, and he built everything off of those basics. And what do we call a basic, or almost points we take on faith in geometry? What are they called? Anybody remember? Things that for some reason we don't prove, they're just there. Now, theory or theorems come up later. Postulates can be proven off of these first things. The unproven things we refer to as axioms, correct? Correct?
Yes.
I'm looking for Mary, make sure I'm not telling you a lie. Like I said, it's been almost 40 years since I've been in here doing anything. Postulate number 1 basically says it is possible to draw a straight line from any point to another point. And now it doesn't really matter if we're on a plane or if we're in space. If we have 2 points in space, we can draw a straight line to them. Now some of the other fields of geometry, the non-Euclidean geometry, they said, okay, let's change that a little bit and see what happens if this postulate isn't true. The second postulate is that it is possible to produce a finite straight line continuously in a straight line. Okay, what does that mean? And first of all, this finite straight line, you call it that anymore. What do we call a line that actually has 2 endpoints? A what? A line segment. So if we translate this into current language, you're saying that it's possible to have a line.
Hit your P button on your computer. There you go.
Well, what I was saying is possible to have a line segment, a finite line segment continuously in a straight line, so we can decide how long it's going to be or how short it is, and it's still going to be in the straight line. And we can pile a whole bunch of them up, like this picture showing. We have a line segment CA, AB, and BD. The third one says that a circle can be defined by a point and a radius. How many of you have ever played with a CAD program at all? Or how many of you took geometry in high school? And in geometry in high school, we use that all the time. Here's a point. Usually, if we are lucky for the rest of our test, it was 0.00, because then we don't have to do the plus x and plus y to get it translated back to 0, 0. Here's a point. Here's a radius.